Yes, children, very good evening. Actually, so we are going to discuss the electrical machines we have because gate coaching is very important and it's very vital also. So when you go for higher studies, you have to clear the gate examination. That is very important. So here we are going to see that in electric in triple E we have a lot of topics involved in gate. So we have a lot of topics. That is, we have instead if we just discuss about the syllabus, you'll be having engineering mathematics. Okay, for triple gate, I am discussing about the triple gate. So initially, you'll be having engineering mathematics. So you'll be having that linear algebra, then calculus, differential equations, complex variables, probability. So gate, what is the thing is, it will touch all the components. Okay, it will be touching all the area of our engineering as well as mathematics. Next, we have that electric circuits. So electric circuits very important, also important topic. From second semester itself, I think you'll be discussing, you'll be learning about this electric circuits. That we'll be having that network elements, all that Kirchhoff's voltage law, current law, all the theorems and all, everything will be coming under this electric circuits. So this in this, what is the thing is a very big problem will be given. You have to solve it. In case of your subject, what you will do is you'll be just solving and you'll be writing. But here there will be a big problem and you'll be given a 4 option, that's all. So you have to solve it and you have to find out the answer and you have to mark that because you'll be having options. But what is the main thing is all the answers will be closely related with each other. So it is very important for you to understand properly and you have to solve it, whether it is given in meter or centimeter or whatever it is, ohms, kilo ohms, then ammeters, voltmeter readings, all the units you have to be very careful. So that thing you have to understand. And third section, you'll be having electromagnetic fields. So in electromagnetic fields, you have the various types of field, electromagnetic field. This is also an important subject. So you'll be going through it, right? So here you'll be using Coulomb's law, then electric field intensity, Gauss law, divergence. So all these various types of law you'll be using in the electromagnetic fields. You'll be learning. So in this also, theory means just they will not give only the explanation or they will not ask only about the law. So what they will mainly do is they will see whether you are having the basic knowledge in all these things. That thing you have to understand. Okay. Next, next one is your signals and systems. Signals and systems. It is you'll be learning about the various types of transform, this Fourier transform series. All these types of series you'll be learning, and you'll be learning about the Laplace transform and Z transform series. Everything will be coming under this. This comes under your signals and systems. Then our what we are going to discuss in this topic is that electrical machines. So electrical machines, what is the thing is, you will be having a single phase transformer. Okay, so here what are all the discussions you are having here is you have to see. So transformers, then you will be discussing about the types of motors, various types of motors you are having. So various types of motors you will be discussing. Then you will be discussing about that machines, induction motor, induction machines, then synchronous machines, various types of induction machines, synchronous machines, and all the types losses. What are the types losses you have, and how the efficiency calculation is done. So everything will be coming under this electrical machines. Then you have the power system. Power systems. So power systems, like, you'll be discussing about the types of various load flow analysis. So various types of load flow analysis, already you have done the lab also, right? Power system simulation lab you have done. So various types of load analysis, load system analysis you'll be discussing, and you'll be discussing about the economic load dispatch of all the items. Okay, that comes under this power systems. Then you'll be discussing. So here, if you see, all the problems are very big problems. You have to solve it. Okay, solve it and you have to find out the answer. So that comes under this power system analysis. Next comes under your control system. Control system, it's also a very important topic. Okay, control systems la you'll be having a various so everywhere if you see in our electrical subjects, all our derivations, all our equations, everything's are present here. So you have to be very careful when you solve it. So here mathematical modeling and block diagram. So we will be knowing about the block diagrams and signal flow graphs, then transient and steady state analysis, everything will be there. Then plots, various types of plots will be having here, right? Root criterion plots, then Nyquist plot, then generally you will be having the root locus analysis. Okay, all these things, Bode plot, all these things will be coming under your control system. Next, it is your controllers, PID and PI controllers, and how the state space model you are going to discuss, that and all, everything will be coming under this control system. So next one is so up to this I think you can understand. Any doubts if you have, you can ask me. As and when you have any doubts, you can unmute and you can ask me. You can have interaction. Okay, so you can interact and you can ask. If you have any doubts, you can discuss. Okay, so here next one is then electrical and electronic measurements. Electrical and electronic measurements, if you see that there are bridges, then measurements will be having all the types of bridges. Okay, we'll be learning a lot of bridges now. You'll be doing the experiment. MI lab also you'll be doing. So here measurement of voltage, current, power, all these things will be there. Next voltmeter, multimeters and oscilloscopes, everything will be for this. Next one is analog and digital electronics. It is a simple diode circuits. So in this you'll be learning about that. You learn to know EDC. In EDC you'll be learning electronic devices and circuits. You'll be learning all these things. So all the types of circuits, clipping circuits, dampers, rectifiers, oscillators, everything will be coming under this. Next you'll be having multiplexers, demultiplexers, then you'll be having sample and hold circuits, analog and digital converters, everything will be present here. Okay, next one is power electronics. In power electronics, static VA characteristics. Then you'll be learning about all this. Is because you have this subject, you have along with that subject you have lab also. So power electronic subjects, all the types of transistors you will be having, like thyristors, transistors, everything will be present here. So MOSFETs, buck boost converters, various types of converters. Because in our research papers and all, recently they are using currently employed different types of converters we are using, right? So all these things will be coming under this thing. Oh, these are all the sections. These are all the various sections you are going to do for the gate. Okay, so I'm just opened from the net, currently opened, so it is easy for you to understand. So these are all the various topics. So now in this we are going to discuss about electrical machines. So in electrical machines we have a lot of subdivisions, lot of topics we are going to have in this. So we'll be discussing about the electrical machines. So I'll start sharing. Okay, electrical machines, it is see the type of questions you are having in see the types of questions you'll be given, how the question is present. Okay, so this is the electrical machines you'll be having here. So here like 1 mark question, this will be like a 1 mark question. So here you will have to discuss about the various types of will be given options like this. So you have to see and you have to write. If you see, all the options will be closely related with each other. That is very important. So you have to be very careful when you are answering questions, because you have negative marking also, no? So you have to be very careful in answering all the questions because I told you also already, all these are closely related with each other. So it is very important for us to be very careful in answering all the questions. Okay, so here questions may be in a shuffled form, it may be in a different form. So we have to be it may be from induction motor, it may be from synchronous motor, everything, it may be from anywhere. So you have to be very careful when you are answering questions. So now let us first see this first question. So what is the first question? First question, anybody can read it out, or otherwise I'll read it out. Okay, so first question is leakage flux in an induction motor. So they are given 4 options in there. Leakage flux in an induction motor they are given. So what are all the 4 options given? Flux that leaks through the machine. So first you should know what do you mean by a leakage flux. What is meant by a leakage flux? So generally flux we know 5. Flux is 5. So they are given as leakage flux. So leakage flux in an induction motor, they are given you 4 options. Flux that leaks through the machine, flux that leaks through the machine, flux that links both stator and rotor windings, flux that links none of the windings. Fourth option is flux that links the stator winding. So if you see, the 4 questions all are closely related with each other, right? So it is very important for us to understand properly, and you have to answer it properly. So that is very, very important. Okay. So flux leakage flux is in an induction motor. So what will be the answer? Anybody can guess? Anybody can guess the answer? So here leakage flux in an induction motor. So what is that case here is you have four options here. So induction motor we have to discuss. So here it can have, see they have given stator, generally flux will be either from the stator or rotor, right? So flux linkage we are going to create. So what is the case here is, first one is it machine, they have given us machine. Okay, second one is both stator and rotor winding, third one is none of the windings. So windings will be involved for flux, definitely windings will be involved. Okay, so in that case your first option is without winding and third option is without winding, none of the winding kuduthirukanga. Yeah, so here first and third option you can reject. So whenever if you answer the question, what is the main thing is, first you have to don't find out the correct answer. First you cancel out all the unwanted answers, then finally you will be getting the correct answer. That is the case here. Okay, so here when you go for four options, first you see which option is very irrelevant to that particular question. So not only for this I'm saying, for all the subjects I'm saying. Okay, for all the subjects you should not just you have to find out the correct answer. First you find out the answer which is not reliable to the particular question. So when you find out that, then automatically what will happen, you can reject all the other one. Okay, so here, so first option and third option you can reject. Then we have only B and D option. So in the B and D option we have to see whether it is both the stator or rotor winding, or it is either stator or rotor winding, but not both. Okay, so the answer for this is option is, it can work as, it can, the link can be from either the stator or rotor, it is not the both rotor. So if you see, the answer is the fourth option, flux that links the stator winding or the rotor, or okay, so there is, if you see the second answer and fourth answer, both will be similar with each other. But what is the thing is, both stator and rotor winding is the second answer. Fourth answer, if you see stator or rotor winding. So we have to be very careful when you answer. So that is your fourth option. So flux linkage in an induction motor will be only by either by the stator or by the rotor. Okay, so if you have to go in this way, not only for this subject I'm saying. So again I'm repeating, whenever a question is given, don't go and find out the correct answer. First you reject all the wrong answers. First you eliminate all the wrong answers. Then finally you will be getting the correct answer. Okay. Okay. Next question, if you see the angle del in the swing equation. So see, they are just mixing and giving all that motors, generators everywhere. They are mixing and giving. So you have to be very careful in answering. So the angle del in the swing equation of the synchronous generator is angle between stator voltage and current. Second one is angular displacement. So del is what we should know, what is meant by del. So for that you should know the subject thoroughly. Okay, students, if you have any doubts also, you please unmute and ask me. Okay, so here you will be having del. Del is the swing equation, and swing equation, if you see, you have various options. So in the various options swing equation, what is the case here is, you have to go for angle between stator and rotor, angle between the stator voltage and the current. Second one, angular displacement of the rotor with respect to the stator. Okay. And the third one is angular displacement of the stator mmf. See, if you see all the four answers, it will be just like you will be getting a confusion. Okay, so you have to be very careful. Then angular displacement of an axis fixed to the rotor with respect to the stator. So anybody can guess? Okay, ma. So anybody can guess? So del action, del, what is the del value? What is the del equation? Okay. So del in the swing equation of synchronous motor. Sorry, synchronous generator. Anybody? Okay. Okay, so here also if you see, it is the angular displacement of an axis fixed to the rotor with respect to the synchronously rotating axis. So one will be fixed, another will be rotating. So L is a swing equation, means swing means it will be going on swinging, correct? So here what is the case here is, it is the angular displacement of the axis fixed. One axis will be fixed and another axis will be rotating. Okay, so that comes under this synchronous generator. So randomly if you take these answers, all these are very, very important. Next, third one, a single phase transformer. So this question is related with the transformer. Single phase transformer has no load losses of 64 watt as obtained from an open circuit test. So we have various types of open circuit test and all we will be learning. All the types of tests you should recall. So whenever a question is given, you have to recall that particular topic. Okay, where it is there, you have to recall that particular topic and you have to find out and you have to recall all the formulae or related with that. When a short circuit test is performed on it with 90% of rated currents flowing in its LV and HV windings. Okay, then it measured the loss. It measured the losses of 81 watt. The transformer has a maximum efficiency when it is operated. So they are asking, they are given as the single phase transformer. It is having a no load loss. Without load, the loss is 64 watt. Okay. Next, then what is thinks it is 90% of the rated current flowing through LV and HV. Then the measured losses is 81 watt. 81 watt. Then they are asking the maximum efficiency when operated. So when it is operated, so we have to find out how it is operated. So in which efficiency it will be having maximum rated current. So that thing they are asking. Okay. So in that case, first you write out what is the no load loss. So no load loss they are given the 90% of the rated load when it is in HV and LV windings. So what is the name of that loss? So they are given when short circuit test is performed on it with 90% of the rated current. So what is the 81 watt is now? What is the type of loss? Anybody can answer me? So what is the type of loss given in the question? So the type of loss first we have to identify. Okay. So the type of loss, what is the type of losses? It is, what are the types of losses you have? Various types of losses. So that thing if you say, it will be easy for you. Yes, we have various types of loss, iron loss, copper loss. So various types of losses we have when the motor is rotating, correct? So here it is being specifically mentioned as copper loss. Okay, so copper loss. So copper loss at 90% load is given as 81 watt. So you have to identify it properly. So next, what is the thing is? So we are going to find out that value. So full load actually copper loss into, we have to find out the current. So we have two types of current, full load current and normal current. So you have copper loss as 81. So 81 into, so that thing I have to say in the screen. 1 minute. So I think the Word document screen is being visible. 1 minute, I will stop the screen and share again. Yes. So they are given. First we'll mention the given date. Okay. So copper loss. It is. So copper loss at 90% of load. At 90, copper loss at 90% load. That is equal to, copper loss at 90% load is given to 81 watts. So that is the given document here. Okay. So here we are going to find out the full load copper loss. Okay. That time only, after that we can find out the efficiency. So full load copper loss, what is that formula you should be knowing? So W, Cu, W, then if in that base you will be putting Cu. So base you are putting Cu, is given as at X percentage. This is for full load. Okay, this is full load loss. Full load copper loss. Sorry. So full load copper loss at full load copper loss. Okay, this is and full load copper loss. So what is that percentage? 81. 81 into then you have that full load current by total current. Okay, 90% of that current we have given. Okay, so all the given data rated current is 90%. 90% is rated current and full load current. Full load current will be having a you'll be seeing that question itself. Okay. So full load current is you always will be putting that value as 1. So when you substitute, this is copper loss for 80%. What is that percentage given? 80%, 81%. So 81. So it is X percentage. Actually, it is X percentage into X percentage into. Then you'll be having two losses. What are the losses? You'll be having full load, normal full load current and as well as the normal current. Okay. So rated current. So Ix I am giving it as a rated current. Ix I am giving it as rated current, and that divided by. So this specifications you can have as your own, no problem with it, because each in every book separately it will be given. It will not be same. So we have to be. You can use your own specifications. So based on the problems. So this is here. So this is the formula. Okay. So this is the formula. So this X it is not. I will just put as a. Okay. So this is the. I will be putting in small letters. It will be easy for you to understand. So this is the equation. So you have to substitute in this for getting our final expression. So how we are going to get. So that is equal to. Again you are going to use this. Is equal to. So this is given as 81. Okay, that is given as that is WCU, that is loss, is given as 81. That into you have two currents. Okay, so here we are going to use 1 minute. So here full load you are given, that is equal to this. Now we are going to find out full load. Okay, so you are going to find out full load. So this will be this will be first here. You will be having full load current here. And rated current. Actually, rated current, this full load copper loss, that is values will be equal to the values of WCU at X percentage load. Okay, this is X percentage load into IFL by. So we can get anyway. Okay, so I want full load means I have to multiply it. So what is that full load current we are going to have in the question? From the question you have to write. So that is 1 divided by. So it is 90%. So 90% means 0.9. 90% is 0.9 squared. Okay, so finally if you solve this, anybody can solve and give me the answer. I'll wait for 2 minutes. Yes, you should be familiar with the calculators, everything you should be knowing. Does anybody solve it and tell, can, if you, it is just a formula substitution, that is very, very important. Okay. Yes. Nobody. Okay. See, please have some good interaction. Okay. And please try to solve all these expressions. That is very, very important. So when you multiply this, you will be getting the answer. You have to solve it. So when you multiply this, you will be getting the answer as. We'll solve it in the calculator itself. So it is 100 watt. Okay. W 100 watt. So here for maximum efficiency. So totally no what is it is losses, all the losses when you add it will be equal to the total loss. So copper loss. So copper loss when the no load losses. So copper loss will be the no load losses. So that will be, they are given some value as how many value, what is the value they have given? They have given as 64. Okay, when no load loss, that equals to the copper loss. So that is equal to 64. So copper loss equal to 64. All these things you have to identify because the problem will be always given indirectly. It will not be given directly. So we have to be very careful. So when we want that full load loss, full load copper loss means that is equal to, we are going to find out. So we know that is full load, already we have found out full load copper loss. Okay, WCU we have found out. So already we have copper loss here. So 100 is the full load loss and 64 is the copper loss. So I want the value of X. So X will be, what is the thing is, it is you are going to divide full load loss by the copper loss. Okay, so that time you will be getting the value of X. So here the X value what we are going to find out will be equal to square root of square root of 64 divided by 100. Okay, so your answer will be 64 divided by 100. You have to take square root of 64 divided by 100. So when you divide this, you will be getting the answer as 0.8. So your percentage will be 80% of load. So this is the, so this one if you see, how much steps it's taking to find it out. So it is very, very important that we have to understand. Okay, we have to understand and we should know all the formulae that time, because we will not be having time to solve. So you should be knowing all the formulae, everything you should be knowing. So that time it will be easy for us to understand. So electrical machines. So again I'm stopping and I'm again sharing. Okay, so here so you have the answer here. So which is the option? So what is the option we found out? So they are asking the transformer has a maximum efficiency. So it is having the maximum efficiency. So what will be the answer? Yes, at the same what is the answer? We found out now. What is the percentage we found out? We found out 80%. See, if you see that Word document, we found out 80%. Right? So option 3 is the correct. So these many steps you have to solve. These many steps are there for solving, and it is very, very important for us to understand. Okay, so 80% of the rated current. So 80% of the rated current is there. So you have to, this third option, see fourth and third options are more or less same. So every time in the gate examination, two options we can take it outside, but other two options definitely you have to find out which one is correct, because both the options will be looking similar to each other. Okay. Any doubts you have, students? If you have any doubts, you can unmute and you can ask me any doubts if you have, please. Otherwise, I'll go to the next question. So these types of questions are there. You have to go through it. Okay, these are all 2-mark questions. Okay, you have to go through it and you have to form, because all these questions you will be writing in 13 mark or 16 mark in your university examination, theory examination. But GATE is not like that. Okay, GATE is somewhat very you have to understand properly and we have to have that speed. Okay. Next question. So I'm going very slowly because for you it will be for you easy to understand. Whatever questions we are discussing, it should be easy for you to understand. Okay. Just randomly, if we go on going, there is no use. And after I discuss all these things, you try to solve all these problems. Each and every problem you try to solve. Take a lot of question papers. So question papers, when you take and solve, you will get a good practice. Okay. When you take the question papers, the old question papers, and you solve it, you will be getting a good practice. So please try to do it properly. Okay. Okay. Next question. A 4-pole induction motor supplied by a slightly unbalanced 3-phase 50 Hz source is rotating at 1440 rpm. The electrical negative sequence current in the rotor is they are given. Okay. Yes. Anybody? At least you just say me what are all the data given. Okay. So data given, everything, that will be easy for you to understand. So again I'll take that Word document. So 4-pole induction motor is given. Then they are given it is a 3-phase unbalanced phase, 50 Hertz. It's having a frequency of 50 Hertz. Speed is 1440 rpm. Okay. Now 4-pole. So it is the number of poles is 4. So first what you do is you just write the given data. Whether you want or not, whether you need the data or not, no problem. So first you should write the given data. Okay. Yes, whether the screen is visible. Yes, ma. Yes, ma'am. Whether the screen is Word document, so I'm just going to do it. So please say me whether the screen is visible.
Yes, ma'am.
Okay, pa. Thank you. Okay, so now frequency is given. Okay, frequency is given as frequency. Always will put it as small f, right? So please put it as small f. Frequency is equal to 50 Hertz. Frequency is equal to 50 Hertz. Then number of poles. So number of poles will be putting in the number of poles. Number of poles is capital P, that is equal to 4. Question I'm just writing it. Okay, number of poles 4. Then speed they have given. Rotating speed. So rotating speed, if you see, it is 1440. Rotating speed 1440 rpm. Now they are asking to find out synchronous speed. Any idea? Synchronous speed, very easy formula. We know that. N suffix S. So this is the synchronous speed. So what will be the synchronous speed? So synchronous speed, you should know the formula. So what will be the synchronous speed, you have to say. So any idea? Okay. Okay, I'll say you the formula for that. Excellent, excellent. Pa. The same thing. Okay, it is 120 F by P. Yes, very good, very good. So we are going to use 120 F. See, it's actually a very easy problem. You can easily score mark in that. Okay. So 120 F by P. That's all. So synchronous speed. Is 120 into frequency. We have frequency, it is 50. Okay, so divided by P, number of poles is. So it's very easy problem and you can easily understand. So you can easily score mark also. Sometimes the problem will be very difficult. Difficult means you have to solve a lot of steps, but sometimes if you see it will be very easy. Okay. So first from that you are going to calculate the speed. So what is that calculation? 120 into 5. So when you divide, you will be getting the answer as 1500 RPM. Okay. This is the speed first we have to calculate. But this is not the final step. Okay. So this is not the final step. So from that, we have to calculate what they are asking to find out. Question, if you see, they are asking a 4-pole induction motor supplied by slightly unbalanced 3-phase 50 Hz. The electrical frequency is given. Induced negative sequence current in the rotor. So they are asking the negative sequence current. Negative sequence current. Okay. So here it is not the synchronous speed they are asking. So we have to calculate that. From that we have to calculate negative sequence, the frequency, electrical frequency. We have to know, give the electrical frequency of the induced negative sequence current. Okay. So they are asking to find out the electrical frequency that is induced by the negative sequence current. So you should understand the question properly. That is very important. Okay. So here we are going to calculate. So first we calculated this. So steps we should be knowing. It's 1500 RPM we have. Next slip. We know the term called slip. So this formula are very, very important. Slip is, yes, we are giving the term as capital S. Sorry. Capital S. So that is equal to formula NS, N suffix S. NS minus N, normal speed, divided by NS. This is the formula. Okay, formula. So NS minus N divided by NS. So here we have this expression. Why we are finding out the slip? I'll give you the reason for that. Okay. So these steps, why we are finding out, everywhere we are finding it out to find out the frequency. Okay. So we have to find out the frequency or negative sequence they are asking. Okay. So question we have to be thorough. Question we have to be just recalling all the questions. So slip will be equal to NS minus N divided by, so 1500 is the NS speed. That is the stator speed we found out. And normal speed is given as 1440. Divided by, again 1500. NS speed is 1500. So speed S will be equal to
0.04.
Yes, excellent. 0.04 is the answer. Okay, 0.04. So this is the slip value we got. Very good. So here the slip value, what is that unit of slip? is there is no unit for the slip value. Okay, because here numerator also you have RPM, denominator also you have RPM, so it will get cancelled. So the slip does not have any unit. Okay, okay, ma'am. Now from that we are going to find out the electrical frequency of the induced negative sequence. So from the frequency you have to calculate. So what is the case here is question, we have to see it out. 1 minute. A 4-pole induction motor, we have 50 hertz rotating at 1400, everything we have found it out. Okay, now electrical frequency of the induced negative sequence current in the rotor F0 will be equal to, okay, now the question is given as 50 hertz, correct? 50 hertz they are given. So what is that case here is electrical frequency, see F0 will be equal to what we have to find out. Similarly, the for which hertz, for we are going to find out for which hertz we are going to find out. So what will be the electrical frequency? So here we have a formula. Is equal to, so it is a small letter, is equal to 2 minus 5 of the small f, F0, this is F0, it's not taking the small letter actually. F0 is equal to 2 minus 5 of f. So for this is the negative sequence frequency. So when you go for this, f is the stator frequency, we know, right? So here F0 equal to 2 minus, actually generally it is 5. Slip we are going to substitute this one, 2 minus this is sorry, yes, actually slip. Okay, so this slip we have found it out as 0.04 into frequency is 50 hertz. From that we can calculate F0. 98. Yes, very good, pa. 98. F0 value will be equal to 98. So this is the answer. So 98, this unit will be hertz because it is a we are going to find out the frequency. So unit is hertz. So these many steps you have to find it out. So when you take this question, see you have that option as B option as 98. Okay. So this is the this type of problems you have to see. See when you go through these problems, we have lot of steps in this. So you have to be very careful in solving out the problems. Okay. So you see that fifth question. You go through this fifth question. 1 minute. This one will be very big. It is time up. So I'll go to this, and tomorrow we'll be having classes now. I'll be discussing about very big problems. Okay. So you take this question. The slip of an induction motor normally does not depend on. Anybody can answer this question. I'll wait. I'll be waiting for 2 minutes. Okay, pa. So better we can discuss these questions tomorrow. Okay, it's already time up. I think so. 8:30 we have started. 8:30 it is. Okay, so these questions we'll be discussing, and the next class we'll discuss. Okay, okay, ma. Okay, ma. Thank you very much. You can leave the class. Thank you.
Thank you, ma'am.
Thank you very much, ma.